Welcome, everybody, and thank you for attending today's presentation on everything you need to know about structural code coverage for C and C++. My name is Ricardo Camacho, and I'm the Director of Regulatory Safety and Security Compliance at Parasoft. And I'm accompanied by Zach Maiga, one of our extinguished solution architects. Why don't you say hi, Zach?
Hi, everybody.
Thank you. Anyway, this is going to be a very informative presentation, so let's take a look at the agenda. On the agenda, I'm going to start by putting code coverage in context and provide a quick introduction to what is code coverage. Then I'm going to touch on the requirements and nuances of standards compliance for code coverage, including the different criteria or types by which coverage is measured. I'll then follow it up by various methods and practices used in obtaining code coverage. Then Zach will give us a live demonstration. This is going to be the really exciting part of the webinar. And then following the demo, we will open things up for live questions and answers. And I actually strongly recommend that you request a custom in-depth demo. And at minimum, come visit our website where we have tons of informational content and really educational. All right, so let's get started. Now, in this slide, I'm going to put things in a nutshell, but I'll be diving into further depth on many of the topics that I'm going to bring up. I want to provide additional detail and clarification because there are various approaches to code coverage, and the language definitions has been overloaded. So I want to make sure we clarify that. But the essence of code coverage is the identification of code that has been executed by way of testing, which helps highlight what parts of the code have yet to be tested. So this helps answer the question, have I done enough testing? At the same time, I will help you flush out, actually the code coverage will help you flush out bugs and identify dead code. You can see in the slide that most of the code is highlighted in green, but there is some red signifying that that particular statement or path in the code has not been tested. Could there be an issue in that untested code? Perhaps. Do you want to risk it? Maybe not. And in some cases, you won't have a choice. You may have to satisfy 100% code coverage. At this point, you may also be wondering, how is code coverage technically achieved? The most common approach is through code instrumentation. This means that the developer's code is adorned with additional code to detect if a statement, decision, or branch has been executed. The instrumentation code logs the execution and coverage criteria type. With this information, a percentage value of code coverage achieved can be shown, as well as code highlighted in green, red, and in some of our code coverage solutions, for example, for Java, C#, VB.NET, you will actually also see yellow, which implies partially covered code. For example, an if statement with multiple conditions, but not all decision branches have been taken. You will also notice that I've listed several testing methods like system testing, unit testing, and others. Many organizations will instrument the code, then run all their system test cases to find out how much of the code has been tested. Many end up with a figure around 60%, and if you want to improve that percentage, you can also do so by combining additional test cases like unit or manual testing. And I'm going to get into this in greater detail later on. But one other very important aspect of code coverage is what structural parts of the code are you trying to obtain? There are various types or control flow criteria in obtaining code coverage. On the bottom right of the slide, you'll see some options like line coverage, statement coverage, block coverage, and so on. I'll skim through some of these in a couple of slides from now, but I'll be focusing on the primary three types for embedded safety critical applications written in C and C++. And those happen to be statement, decision coverage or branch, and modified condition decision coverage, more commonly referred to as MCDC. Again, some of these terms have been overloaded, but you may be wondering why these particular coverage types. In the embedded industry, C and C++ code is used in safety and security critical systems. These industries have regulatory requirements and process standards to follow for compliance. I've listed some of the most common ones here: ISO 262 for automotive, DO 178 for Milero, IC 62304 for medical. And there are safety integrity levels, A, B, C, D, or 0 through 4, that can be assigned to the code. This assignment value can recommend or highly recommend, or in some cases, mandate that additional rigor or actions be applied during testing. For example, the table on the bottom right is a snippet of IEC 61508 standard for industrial automation. If your software is assessed at SIL 4, which signifies higher risk to the system or personnel if the software fails, 100% code coverage for entry points, statement, branches, and MCDC is highly recommended. The common theme for the safety compliance standards is code coverage for statement, branch, and MCDC. These coverage types are selected by the standards working groups, which is comprised of various companies in that particular industry. These recommended best practices help ensure that the code deployed is of high quality, so safe, secure, and reliable. Let's now touch on some of the other coverage types, but be aware that the terms have been overloaded and you may find a different meaning or interpretation of the code coverage type. Some of this is due to some standards defining their own coverage criteria. Other interpretations come from different domains like the IT and web applications, and coverage requirements are where they're very different, particularly from compared to embedded development. For example, DO 178C defines decision and decision coverage, which can make it confusing. Decision coverage equates to branch, and Parasoft implements decision coverage as branch coverage, so important to note. To quickly reiterate on how coverage happens, as the application executes due to test cases, the instrumentation can be set up to evaluate various control flow criteria. At the top, we have function coverage. It answers the question, has each statement of a function or unit in the program been executed? The next type, called coverage, determines if each function in a program has been called. Function and call coverage may sound similar, but they do different things. The next two types are also interesting in a different way. Statement coverage determines if each statement in the application has been executed, while line coverage determines if every line of the code has been executed. So how do they differ? Well, you can imagine multiple statements on a single line of code as highlighted in blue. It counts as one line of code, but two statements. Therefore, you will have different value results. At one time in my career, I used to deliver services in unit testing and code coverage, and this metric used to raise a lot of questions about the difference. It's important to understand the subtle differences. However, it can get kind of confusing with some of these types. And if the code is complex, it compounds the issue. So let's decompose decision coverage, also known as branch coverage. A branch can have conditions and or decisions. They are subsets of a branch. Condition coverage checks individual outcomes for each logical condition. If we just consider conditions, they evaluate to true or false based on relation operators such as not equal, less than, greater than. And as you can see in this example, I have a less than 7. To achieve 100% condition coverage, test cases need to demonstrate that a true and a false outcome occurs. This will need two test cases, a test case where A is equal to 0, which satisfies a true outcome, and a test case where A is equal to, say, 9, which satisfies the false outcome. Now, decisions are expressions composed of conditions and one or more of the logical operators and or. To achieve 100% decision coverage, your test cases must demonstrate a true and false outcome for each decision. Now, a branch is one of the possible execution paths the code can take after a decision. Branch coverage ensures that each decision condition for every branch is executed at least once. However, there are some complicated code constructs where branch coverage is insufficient, and we can then get into edge coverage to help support all of the complete coverage. However, We don't have the time to go through all of these listed, but I would like to go through actually the MCDC and MCC. Modified the condition decision coverage and multiple condition coverage. MCDC coverage is a combination of branch, condition, and decision coverage, but much stronger. It answers the question, have all conditions within decisions been evaluated to all possible outcomes at least once? Therefore, you must ensure branch coverage that every control statement takes all possible outcomes at least once, that every condition takes all possible outcomes at least once, and that each condition in a decision has been shown to independently affect that decision's outcome. And this is an important point. The top table helps illustrate this. If you take the condition decision statement shown at the top, it has three conditions, C1, C2, and C3, and two decisions, an OR and an AND. Based on MCDC requirements, if condition 1 is false, and because the decision is an OR, you need to evaluate conditions 2 and 3 to determine effect on outcome. However, if condition 1 is true, the outcome is automatically true because it's an OR. Therefore, you don't need to evaluate conditions 2 and 3. There's actually a formula for MCDC in determining the minimum number of test cases required to satisfy 100% MCDC coverage. It's the number of conditions plus 1, and the table clearly illustrates this. Now, for multiple condition coverage, it answers the question, have all the possible combinations of outcomes of conditions within decisions been tested at least once? The MCC table to the right shows that all possible combinations have been considered. Now, the MCC formula for number of test cases in a condition decision statement is 2 to the power of the number of conditions. So in this example, 8 test cases are required. An interesting point to make here is that adoption of MCC coverage has been debated. Yes, MCC coverage offers more thorough testing. However, I have not noted any standard mandate MCC. Perhaps it's because of the sheer number of test cases required to achieve 100% MCC coverage. Note that in our example here, the number of test cases double. This could very well impact the labor cost and time to market schedule. Be aware that Parasoft CC++ test has made MCDC configurable to expand beyond the minimum MCDC test case requirement. So it's configurable. Anyway, these were the core coverage types that I wanted to go over. Let's now get into automating and obtaining code coverage. Coverage Advisor, it's a really cool feature in helping you define code coverage test cases. All you need to do is hover over a line of code and right-click on it, and then select, Show in Coverage Advisor. And analysis kicks in, and a window such as the one you see on the right pops up. It provides you with preconditioned parameter values and stub values for unit test cases. In order to achieve code coverage for that line of code and other lines as a byproduct as well. And you can see a little bit of picture on the far right. It's the GUI, so that's where you can specify some of those value parameters when you create those unit test cases. And a long time ago, I used to perform code coverage at various companies for various industries. And sometimes it got kind of tough figuring out what values were needed to hit a particular statement. I could have really used this feature to expedite that offer. There is, however, a very quick way to get started. So let's take a look at automated unit test case generation. Parasoft CC++ test can automatically generate unit test cases, not just to help you with unit testing, but to also help you achieve your structural code coverage requirements. It's very simple to do. You have multiple configuration windows with very numerous options to create your unit test cases. By default, CC++ test creates smart test cases. By smart, I mean test cases that actually look for bugs, not just sunny day scenario test cases for code coverage only. For example, null pointer test cases, min mid-max type of test cases, and even boundary value test cases. And based on the complexity of the code, you can achieve very high code coverage results. I don't like to provide a number because it depends on various factors like complexity, number of branches, conditions, nesting of if statements, loops, and more. If I had a given opinion, I would say 40 to 80% code coverage. But there's also various testing methods that you can use in collaboration to gather code coverage. So I want to also discuss some of those. Structural code coverage can be obtained through several testing methods like system testing. Organizations need to test a system, so why not apply all of their system tests to instrumented code and automatically obtain a majority portion or a large portion of code coverage with little to no effort. This is one common approach I've seen out in the field. However, be aware that system testing does not get you to 100% code coverage if that happens to be your target. I'll say 60 is what I've noticed as a common result. There's been much higher and there's been lower. The reason is because there's a lot of defensive code in the application, defensive code that only gets executed upon encountering a condition like memory corruption or other type of fault. Perhaps code that handles a hardware failure, which may take weeks, months, or years to encounter. Other examples of defensive code come from your own coding guidelines. For example, you must include a default catch for all switch case code constructs. I've written multiple switch and case statements where I know that the default case will never be reached because every possible case is accounted for. And there are plenty more examples, but the point I want to get to is that you may require combining test coverage from other testing methods to get you to your coverage target. Unit testing is one of those methods most commonly used. You can create unit test cases that invoke defensive code or set up conditions that get you to execute uncovered code. Parasoft provides the ability to bring together these code coverage results from various testing methods and combine them into a total coverage tally. And be aware that these industry functional safety standards that I mentioned earlier allow the merging of code coverage metrics. Now, you can see in this slide a screenshot of coverage metrics from unit testing, integration tests, and manual tests, which combined provides 64.3% coverage achieved. At the bottom, you can see a total of 368 test cases combined, which is the sum of all the test cases values that you see to the right. So one other challenge that I like to address is obtaining 100% code coverage. If your requirement is 100% code coverage, you may run into a scenario where a statement may just not be attainable through testing. For example, in the code screenshot to the right, there is an infinite for loop, and a return statement follows that for loop, but it won't be reached. These kinds of scenarios are common, so my recommendation, which complies with the functional safety standards, is that you validate that code coverage by inspection. In this example, by debugging the application, you can edit the call stack or simply jump to the line of code that you need to coverage for. Visually witnessing the execution of the code satisfies coverage through inspection. You can then log that statement as covered. There are also cases where you want to integrate code coverage into your CI/CD pipeline, or perhaps you have a legacy standalone application or libraries that are external to your current development. Well, Parasoft has coined the term application coverage by providing a coverage tool that integrates into the build process to instrument the application and collect raw coverage data. The coverage tool is called CPP Test CC. And actually, Zach is going to be demoing this capability. So it's really, really cool. You can see a command line example on the slide. It also specifies statement coverage, and there are an extensive set of coverage type options available. Anyway, collecting coverage involves three phases: instrumenting the application by integrating the CPP Test CC tool into the build, execute the instrumented code through testing, which produces the raw coverage data, And then to review the coverage, you can input the raw coverage data, which will be in the form of a file called CPP test results CLOG, and then you can bring that into a C++ test project of the application code. The code will be highlighted and code coverage metrics will show within the IDE. This gives you a clear understanding of how well the application was tested and give you a sense of the risk entailed in perhaps adopting this application. So Zach is again going to be demonstrating this. There are many times in the embedded industry that testing, including code coverage, be performed on the actual target hardware. This happens for safety critical systems that you find in the medical device industry, aerospace, and others. And some of these embedded devices are constrained by their limited resources, such as memory size, and usually there's no file system, connectivity issues, or limited connectivity options. And for example, in some cases, the only port available is a serial port or a JTAG connector. Anyway, the testing solution we offer is referred to as cross-platform testing. CC++ test is offered with a test harness optimized to take minimal additional overhead for the binary footprint and provides it in the form of source code where it can be customized if platform-specific modifications are required. We don't have the time to get into the details, but Parasoft C++ test provides comprehensive embedded testing by automatically generating an extensive set of test cases that can be executed on the host, a simulator, and on the actual target environment. This is done to verify code robustness, detect memory problems, verify functional results, of course, obtain structural code coverage to satisfy certification requirements. A best practice I like to convey in the increase in code size due to instrumentation, if it prevents the application from downloading onto the target, what you would want to do is instrument half of the code, run your test, and capture the coverage data. Repeat this process with the second half of the code instrumented and the first half uninstrumented. The coverage data collected can be merged for a full coverage report. Assembly code coverage or object code verification is required for compliance to DO 178C Level A software applications. This is due to the high level of safety required and the fact that a compiler or linker generates additional code that is not directly traceable to the source code statements. DO 178C Level A code coverage requirements are also the strictest in the software industry because it's in addition to satisfying 100% statement branch and MCDC coverage. Imagine the rigor and labor cost of having to perform this task. Fortunately, there is Parasoft Assembly Coverage Tool, ASM tool. It automates obtaining object code coverage and satisfies the executable object code recommendations set by DO 178C. With little effort, ASM tool generates structural code coverage reports from executable object codes that are easy to review, as you can see from the screenshot. Also, the ASM tool supports collecting structural coverage from both target hardware and from the desktop development environment using CC++ test. I want to provide a bigger picture on Parasoft solutions on CI/CD and DevOps because it's one of the largest struggles organizations faced and how to improve testing efficiency while also meeting development needs for safety, security, and quality without impacting schedules and cost. Arguably, one of the solutions that has shown great results is in a continuous integration, continuous delivery workflow. Therefore, many organizations have adopted an agile DevOps methodology. Now, Parasoft's continuous testing leverages automation for static analysis, unit testing, and yes, code coverage. The results derived from testing within the continuous integration workflow provides real-time objective assessment of the risks associated with a system under development. Testing applied uniformly allows both businesses and technical managers to make better trade-off decisions by understanding the quality of their software. Has it been thoroughly tested and all those other wonderful things. And Parasoft is heavily vested in continuous testing. We're committed to offering solutions that facilitate companies adopting an agile CI/CD workflow and continuous testing. We have integrations with GitHub, GitLab, Azure DevOps, Jenkins, Jira, Bamboo, and other solutions such as containerization. You can actually find a Parasoft C++ test image on Docker Hub. Okay, I'm gonna now move on to the demonstration. So Zach, I'm gonna go ahead and hand it over to you.
Okay, thank you, Ricardo. So, okay, I'm going to share my screen. Okay. First, I wanted to show you just 2 slides, so to explain what we are going to, what I am going to show. First of all, I am going to show the coverage in the context of unit testing. So, and I will show you the different coverage metrics we do have in our solution. Then I will show you the application coverage from command line mode. So you can integrate this command coverage tool into your build system. You can apply it on your standalone application whenever it is based on IDE or whenever you use command line to build the application. Then I will show you the visualization of results in Eclipse and also in in VS Code extension here. You see, VS Code is getting very popular, and you can simply use our plugin, C++ test extension, and visualize your coverage metrics directly in this tool. Okay, so and the last thing is to show you the coverage dashboard in DTP. Okay, so let's go on. So I switch to Eclipse. This is a C++ test. This is the Eclipse version. The tool is also available as a plugin for Visual Studio. We do also have an extension for VS Code, as I said before. So the tool is available on Windows and Linux. So everything I'm going to show you here is also possible on your Linux platform. So here we are in Eclipse. I do have a few projects. I have C++ project here. I have also C project here. So the principle is the same. So it's independent on the language. So you can apply the coverage module, coverage information on both C and C++. So I have a small application. When you can see a few functions in it. And first thing I'm going to do is to generate test cases. So I'm going to show the coverage in the context of unit testing. I select my application and then I'm going to generate test cases. I go to built-in, I go to unit testing, and you see I can click on this configuration and automatically the tool will generate. You see, I got in a very quick way, I got 29 test cases in less than 1 second. So if you had to generate those test cases, it will probably take you days. So with our unit testing, automatic unit testing generation engine, you are able to get thousands of test cases very quickly. And then you just have to analyze the inputs and just modify them if needed. So here is Test Case Explorer. You can see I activated statistics. For the moment, they are blank because I did not run the test yet. But we can simply visualize a few test cases. So you can see I have 10 test case for handle sensor value. I have 1 test case for initialize function. The number of test cases will depend on the prototype of the function you want to test. If a function has inputs, global variable, some argument, and depending on the number of arguments you have, the combination can be very consequent. So here, for simple function which doesn't have input, in general, we just call them, and this is why you see a few test cases here. Okay, so let's see how a test case looks like. Handle sensor value. You can see the prototype of the function here. We remind you this prototype. So this function need an input, an integer input, and will return nothing. Okay, so it's a void function. So in order to call the function, we have what we call precondition. We have to prepare test input and call the function. This is where we call the function, and then we capture the behavior of the function in the post condition block here. Yeah, so we can check our test case 2. So here we use 0, we call the function with 0 value. In the test case 3, we use -1, and the message, which is a global variable, is 0, and so on. Okay, so I have my test cases. You can see the test cases are in the source code format. You are free to modify them. You see, it's always quicker than to have to create all this harness. Yeah, so this is one of the advantages of our unit testing framework. So I can modify, I can customize. If I need to call function, I am free to do anything I want into this test case. So let's just run them. I select my test. I am going to run them now. So I go to test using, okay, or I have history. I'm going to run my unit test with all coverage metrics activated. So you see, this time we are going to compile, to link, and to execute. So it's finished. So all test cases have been executed. I get confirmation here, and I have a status of 11 test case pass and 18 test case failed. I can see that the failure are runtime exceptions, and no execution issue, no assertion failure. And I can see also the unverified outcomes. They are the result of the test which pass. They pass, but we cannot guarantee you that the results are correct. So as a developer, you have to go inside, verify the input used to call the function, verify if the output is consistent, and then validate this functionality. So you can see how the coverage we calculated during the execution of the test. We see here line coverage. We have 81%. We have 34 lines executed over 42. So you see automatically how we are able to give you a very good coverage. So we will see later when we analyze the test result which line are not executed and why. So you can create stub if you want, or you can fix problem if the problem is related to a crash, and so on. So you see line coverage, statement coverage, block coverage, function coverage. All those metrics are calculated, can be calculated for you at once. But you are not required to calculate to activate all metrics. You can just choose the metrics you want to apply. I show you how this can be done easily. I go to test configuration. Okay. Then I go to my to the unit test that I run. This is the configuration I run. I go to the execution part, and here you see, this is where we see the custom instrumentation, the instrumentation mode. You can click on this and you have access to the different metric, coverage metric. You can activate the one you want and simply disable the one you are not interested in. Okay, so coverage can be done also, can be activated, can be run also on the targets, and for targets, we give you possibility to instrument the code in optimize Y. You can optimize for size. You can calculate, instrument the code to optimize for size, or to optimize for speed. So this is possible. This is where you can configure, activate the coverage metric you would like. Okay, let's go back to our results. So we have a dedicated view to analyze all this. We have a coverage window here. I can open it and I see the information I have. I have a coverage at the application level. I can see the coverage at the module level. I see the coverage for each source file, and I can also see the coverage for each method. So I can see here, you see that some functions are covered fully covered, 3 lines out of 3. I see some other functions are not covered very well. So main loop function here is covered partially, so 7 lines out of 11. And they can see, you see, this visualization is very nice. It gives you a quick insight in which line are not covered. And you can also see, if you put the cursor here, you can see how many times you see hit count in the info bill, how many times this line have been executed. So green for covered lines, pink color for uncovered lines. So you can see its main loop. So we generated one test. We have one test for it, and the test crashes. So we can also see why this, where the test crashes. We click on show view in task, and we see that this test crashes here. This can explain why some lines are not covered, but you have to analyze this. We see here we have access violation exception. I can double click, I go to the line, and I can see exactly where we have. So we are manipulating some data which are probably null pointer, and this lead to the problem in this code. Okay, so yeah, this is what you get with our coverage engine. So this coverage view allows you to view only a single view, a single metric, coverage metric at a time. If you need to select a different coverage metrics, you select the menu here. You have access to all coverage metric we calculated. So let's see, I want to see modified MCDC coverage for this file. You see, when I activate it, I see I have 56% of MCDC here, and I can see which line this function, for example, has 4 conditions, and all conditions have been executed. So this function has 1 condition, and the condition has not been executed. So let's go back to the function. Here you see, if you highlight the cursor here, you can see all value or condition tested, value tested here, you see. So this helps you to create or to simulate the condition in order to cover other part of these conditions. Yeah, so you see, this is very interesting. You have this information. You can integrate this tool into your pipeline, automatize your regression testing, and have a control on your coverage data. Yeah, so I can generate also, I can publish coverage data to DTP. I can also generate local report here. So when I send data to DTP, I will have this information in DTP. So here in DTP, we can see that we have, sorry. So in DTP here, you see DTP window, and we can see that here we have different dashboards. DTP stands for Data Development Testing Platform, and we do have here possibility, you have possibility to create a different kind of dashboard you would like. So let's focus on coverage data. So you see in the default dashboard, you can display coverage information, but you can also have a dedicated coverage dashboard here, and you see information related to our project. You can use the filter to select the project you are interested in. You can click to drill down and see exactly which part of code have been executed and which part of code have not been executed. Okay, so this is DTP. Again, DTP can store, you can use it to populate it with your coverage test result, coverage result, static analysis result, and your functional test also can be published to DTP. So let's go back. So what I have shown you is the test in the IDE. So the coverage module can be also used in a standalone way. So for this, we provide the tool called CPP test CC. Okay, so it stands for CPP test code coverage analyzer. So you can integrate it into your custom build and generate instrumented executable, exercise this executable, and at the end we will create a coverage log for you. Yeah. So here I prepare a few tests. We have ITM. Let me show you how it's structured. Yeah, sorry, it's here. So we have, sorry, it's timer application. And you can see this timer is based on CMake, use CMake for the build. We can, I can show you how we integrate. So you see we use this particular include CPP test coverage module. So this is our extension, extension for CMake. And this coverage file, CMake file, has all information you have to use to instrument and to build. Let's open it very quickly. So I'm going just to open it in a notepad. Okay, so here you can see, yeah, this it's contain information. You need to specify the compiler ID here, the compiler you want to use, and here you can see the coverage flag, the coverage type flag you can activate: line coverage, block coverage, statement coverage, any coverage metric you want to activate. You just have to specify it here. So if you just need statement coverage, then you can use this, but this part is commented out. And we provide also automatic build of our runtime here, you can see, and so on. So let's use command line to do. I have my project, ITM project. I already prepared it for to be built. I just click on make, and yeah, so you see we are instrumenting the source file here, and we created a timer executable. I'm going to launch this timer executable to exercise it. In my manual execution here, you see I can play with the application. I can add a timer. I can remove a timer. I can list all timers. I can show time. I can exit. Let's use the first scenario. In the first scenario, exit mode, just to see what coverage we got. So very small scenario, and let's see what coverage we got with this. You see we have a specific target here that we call, and this target will analyze the coverage data, yeah, and show us what has been achieved. You see this very simple test produce 41% of coverage. I have 46 line out of 112. I have a good statement coverage, and so on. Let's play again our application, run it. I want to increase my coverage. I am going to play another scenario. I am going to add a timer. I am going to add sometimes some information. Yeah, just playing a scenario, and here, yeah, Yeah, and then I exit. Yeah, this scenario is a little bit complex, and let's see what coverage it produces for us. Okay, so let's see again. Okay, so we see if our coverage, yeah, you see, now I increase my coverage by almost 30%. I have now 60% of line coverage, and all metrics have been increased here, except MCDC, because we have specific condition, and we have to verify which condition are not met, and make sure we have a scenario in order to cover this. So what I see here, you see, you can also get it on your application, on your standalone application, without going from the IDE. But you see, this give me only information. To visualize coverage data, I will need to open coverage logs in the IDE. I can open them in visual in VS Code, or I can also open them in, for example, in Eclipse or in Visual Studio. So let's switch to a proper workspace to see what happens. I am going to switch to my timer workspace where I build my project. So I restart Eclipse just to visualize what happened here. Okay, it is starting. Okay, so just a few seconds again. Yeah, now you see I open my workspace, the test that I did from the command line, and I can see what is interesting. I have now coverage view, and I can see the coverage data, the same coverage information that I got here. Now I can analyze them. Line coverage, I have over metrics. Do you remember here? Let's see what happened. We have a timer here. Okay, so I can click on timer. I can see that add timer has been executed, and we see the path I covered, add timer. Here we can see also over files. We can see that the main loop has been executed. We have information. This is where I click on add timer. We can see which line has not been covered, and so on. Okay, so I can exercise my application at this time, and switch again to the command line, increase, play some scenario, just refresh this workspace, again, or use the specific configuration here we have in order to, for example, it's called load application coverage. Sorry, it's in utilities. Load application coverage in order to update this coverage data with my new test scenario information. So what I show you here can be done also from VS Code. If you need to see VS Code, you just start VS Code here. It will show you here. Okay, so if I start VS Code here, we can get the same visualization of our project in VS Code. Yeah, so okay, yeah, so this it's as I shown in the screenshot before. So this sorry, I started from I did not start it from the source code. Just sorry. I need to start it from the source code to get my data. Yeah, so here I can see I have my files. I can load, I go to palette, command palette, show my, for example, show my coverage data. I can also simply import my coverage file here. So let's see if we have coverage data, line coverage, and you can see the coverage produced by my command line scenario. My command line build is displayed here. Okay, so yeah, this is a quick tour. Again, we can say, we can talk hours about this coverage module. It is very interesting, and Parasoft is the only editor providing you all those metrics. We have competitor, but they provide you with one or two metrics: line coverage, which is very easy, statement, but to get a tool which combine all those coverage metric, you have to go with Parasoft. Okay, so do you have any question? Ricardo, back to you.
Okay, all right. Let's stop sharing, and then I will.
Okay. I
We
don't
will.
know if there is questions.
Yeah, there's a few questions that I want to go over. And Zach, that was a great presentation. I know that this topic has a lot of content to talk about. And Zach just did a fantastic job of showing you coverage through the IDE and a lot of different options, and then through the application coverage, the command line options as well, and how to bring it into various IDEs. So he showed the VS Code as well. That was really, really fantastic. Thank you, Zach, for that. And anyways, if you want to learn more about CC++ test and all of its other capabilities, because again, it's a very rich, capable tool, request a custom in-depth demo. You can use the QR code, or if you have any questions after the webinar is over, send us an email at info@parasoft.com. If you happen to be debugging or want code coverage in other languages such as Java, C#, VB.NET, you can have QR codes there for those products as well, and you can learn more. So at least visit our website. You can also follow us on Twitter, Facebook, LinkedIn. And okay, I'm gonna go ahead and open it up for questions. We have actually interesting, a couple questions that talk about multi-threading. Does coverage module work on multi-threaded applications? And if it does, which thread APIs are supported?
Yeah, sure. This coverage module can be used on any kind of application, including multi-threaded application. So depending on the platform, if you are on Windows, we do support Windows threads. If you are on Linux, we do support Unix threads. If you are on embedded target, we do have VxWorks threads. If you have a custom threading, you can also implement this in the tool.
Okay. Great. We have another question. Can coverage instrumentation be optimized in the embedded testing context?
Yeah, we know that embedded development, embedded target have very little resources. So what we help you, we give you possibility to use the instrumentation in order to optimize either for size, to have a little footprint, or even for speed, if you need more speed, more performance on application. Yeah, it's possible.
Another question, can I use this on shared libraries?
Yes, you can use it on shared libraries. So you instrument, the principle is the same. You instrument your source code. We add all information necessary. We create map, we record the code structure. And then when you apply your functional test or your manual test, we will simply dump coverage information on the part of the library which have been executed. Yes, you can get coverage information on your shared libraries.
Okay. There is, can coverage produced by multiple runs be merged?
Yes, yes, you can have you can spread, for example, your testing activities between teams on different machines. If they work on the same project, yeah, you can collect coverage data locally and combine or merge all coverage data to have a big picture on the application for the application level.
Okay. Let me see. There's another question. How much slower will my instrumented code run? I don't know if we have any metrics on that,
It,
but go
Yeah,
ahead.
it's really depend. It will depend on many factors. The complexity of your code. It will depend on also the type of application. If you have, so many
Mm-hmm.
factors. But again, you are not required to activate all code metrics. You can just start with a single metric, run the application, and so get this coverage, store it somewhere, activate over metric, and so on. Yeah, you are also not required to instrument all part of code. If you are interested in a few files, you can instrument those files and get coverage on them, and again store them and reuse them in a combination of over test activities.
Mm-hmm. Okay, so one last question. How to prevent corruption of coverage data?
Okay, so corruption might happen for different reasons. If you have multi-threaded applications, trying to, but we do have options in the tool which can help you, to protect against corruption. Yeah, so just
Mm-hmm.
contact us if you have any corruption. Contact us. We can give you indication what to do, which option to activate in order to prevent this.
Okay. So that seems to be questions. Well, there. I'm going back to the question on multi-threads, and I know we support all of that. Do we provide any kind of executed time for each thread?
No, we don't have this kind of
Yeah.
no, but you can at the thread level, so you can just have your own printing,
Mm-hmm.
to
Yeah. There's
log
various.
yourself,
Yeah.
but
There's
we
various
don't
ways.
do this.
Yeah, there's various ways to analyze the thread execution time or execution time within functions, threads, whatever. Okay, so anyways, that's all the questions that we have. And Zach, thank you very much. That was really very informative. Actually, this presentation went longer than we thought, so that's a good sign. And thank you, everybody. Please come visit our website for other webinars that we have every month, and we have multiple. Okay, so anyways, Zach,
Thank
let's
you. Yeah,
thank
thank
everybody.
you very much.
Okay,
And
bye, everybody.
and
Bye bye.
let us know if you have questions.
All right, bye bye.
Bye bye.